We're going to talk about solving quadratics using square roots. This works the best when there is no b term or middle term. So that's the first thing you need to look for. Is there a b term or just something with just an x, not an x squared? So we're going to start with level 1. There are a couple levels on this one, so we're going to start very simply. So the first thing you have to be able to do is get the x squared by itself and the number by itself. So we're going to move this number over and we're going to get it by itself. So we're going to take plus 49 and plus 49, and we end up with x squared is equal to 49. So then we want to know just what x is. So we're going to take the square root of each side. The square root undoes something that's squared, or an exponent of 2. So these cancel each other out, and I'm left with x. And then the square root of 49 is 7. But be careful. This could be a positive 7 or a negative 7. So if we think about this, a negative 7 squared gets us 49. As same as a 7 squared gets us 49. So this is a positive or a negative 7. So your roots for this one would be a positive or a negative 7. All right, in our second example, we would do the same thing. You want to get your x squared by itself, and then you want to solve for your x. So pause the video and try it on B and C. Okay, B is pretty straightforward. We got x is plus or minus 12. And you can always plug these back in and kind of visualize where those would go. You know whether or not it opens up or down, has a minimum or maximum, and you can easily see whether what the AOS would be, because if there's no B, that means it's a 0. So 0 over whatever is still going to be 0, so it's going to be at the origin. And they're kind of splitting off equally. C, however, is a little bit different. If you'll notice, we have at the end, x squared is equal to 20. So we take the square root of each side. 20 is not a perfect square. So we can leave our answer as x plus or minus the square root of 20. Or if you put it in your calculator or estimate roughly, it's roughly around 4.5. A little bit less, but 4.5. So x is approximately a plus or minus 4.5. Because it's not a perfect square, this is an example of an integral root, which we learned previously. So these are integral roots. All right, let's go to level 2. Level 2, you'll notice, is a little bit different. It's not got x squared by itself. We're still following the same premise. We're still going to get x squared by itself, but we've got to do a few things first. So we're going to first take and move over the 27, so plus 27, and we end up with 3x squared is equal to 27. Well, we want to get the x alone, or x squared alone, so this is being multiplied right now, so we're going to divide by 3, our coefficient of 3. Now we have x squared is equal to 27 divided by 3 is 9. Again, I just want to know what x is. This part you must do. So square root of both sides. That cancels that away. And the square root of 9 is 3. Do not forget that it's a plus or a minus. It could be a positive or a negative 3. So that one's a pretty simple one. You had to do one more step. Pretty easy. All right, let's look at B. I want you to try that one on your own. So pause the video and then see what you can do. So when you look at this one, you'll notice at the end you get something that's plus or minus the square root of 45. 45 is not a perfect square. So this is, again, another example of the integral root. If you use your calculator and you get approximately, it's approximately 6.7. Remember, again, don't forget your plus or minus. You can leave this answer as either way to help you. Now, of course, when you're plotting it, if you were to having to graph it or to know kind of where it is on a graph, this decimal is going to help you much more than the square root of 45. All right, let's look at C. This one has a fraction in it. So we're still going to follow the same directive as before. We're going to get the x by itself, or x squared by itself. So we're going to plus 9. We end up with 1/4 x squared is equal to 9. Now, anytime we have a fraction and we don't want to deal with that fraction, we can clear the fraction. So we're going to multiply the whole thing times the denominator of 4. This becomes just x squared, and then 9 times 4 is 36. Now we're down to a very simple problem. Take the square root, we have x is equal to the square root of 36, which is 6. And don't forget your plus and minus. So, very simple. Let's move on to level 3. Now, level 3, we have a few more steps to take into account. So I will do the first one, and then I'll let you try one on your own. So this first one, we have a number over here that is not 0. That's okay. We got to get the x squared by itself in this format. So we're still going to do plus 6. We have 2x squared left over here. And now we have 32. Now x squared is not by itself. So we're going to divide by its coefficient of 2 by 2. We're going to be left with x squared is equal to 16. When we have it to this format, we want to know what just x is. So we're going to take the square root of both sides. We have x is equal to, and the square root of 16 is 4. Don't forget your plus and minus. Pretty simple. All right, try B on your own. Pause the video and then come back and check. All right, when I solve this one, and I get it all by itself, I get down to the bottom, x squared equals 50 over 4. So I can then take the square root. I have x plus or minus the square root of 50 over 4. That's not as simplified as I could get it. So I simplified my fraction underneath my radical sign. So I have 25 divided by 2. I know that's not a perfect square. 25 is not a perfect square and 2 is not a perfect square. I have to have them both to be a perfect square in order to simplify it down further as just a fraction. So I could leave it as plus or minus the square root of 25 over 2, or again, this is an integral root, approximately 3.5. And remember, it's a plus or minus. All right, so here's a little quick cheat sheet to kind of help you remember how many solutions you would have based on this method. So if you get down to the bottom and you have x squared and it equals a positive number, you're going to have 2 solutions. If it equals 3, whatever it may be, they may be integral roots, they may be whole numbers, but there's going to be 2 solutions. If you get down to where x squared and you have it equal to 0, when you take the square root of both sides, there's no more than one solution when it equals 0. So one solution is always when it equals 0. If you get down to where it equals a negative number, if you take the square root of a negative number, that's an imaginary number. And those are not solutions in quadratics at this point in Algebra 1. So this would be a no solution. So let's try a 4-star and see what you can do. Pause the video, attempt something, and then come back and check your work. On this one, I want to get the x squares alone, so I've got to move some things around, and I want the numbers alone. So plus 8, end up with 4x squared is equal to 2x squared minus 12. Then I want to get the 2x's over. So I have all my x squareds on one side and my numbers on the other side. Now I want to get my x squared alone. Get rid of that little piece of writing there. So I end up with x squared is equal to negative 6. And immediately when I see a negative number, like on the cheat sheet a while ago, x, those cancel out, I'm going to get an imaginary number. This is a no solution. So here's an example of what you would see with a no solution. Now for a procedure, we always check before we start with this method, is there a b term or a middle term? You want to get x squared by itself using your equation rules, and then take the square root of each side. You're going to state the roots and remember if they're to add the positive and negative. And you can always check to actually make sure it works by plugging it back in, and then visualize your graph to make sure you kind of understand where it's going to be. All right, you have some practice with this. I'll see you back soon.